Support for today's episode comes from Amazon. Amazon is working toward a carbon-free energy future, doing more with less, investing where it matters most, and supporting communities where we operate. U.S. nuclear buildout faces heavy forging capacity gap. DOE's $17.5 billion conditional commitment could speed up purchases and reserve manufacturing capacity for 10 new AP1000 reactors. It cannot recreate, on that timeline, the heavy forging supply chain the United States allowed to disappear. The components those reactors need most still depend on a small, internationally concentrated network of qualified suppliers. On June 23rd, DOE's Office of Energy Dominance Financing conditionally committed up to $17.5 billion in loan financing to help Westinghouse and as many as 5 utility or energy company partners purchase long lead equipment for 10 AP1000 reactors, organized as 5 projects of 2 units each. DOE says the financing could accelerate deployment by as much as 3 years and supports a goal of having all 10 under construction, with complete designs by 2030. Westinghouse has signed letters of intent with 7 potential partners, but the 5 that will ultimately receive financing have not yet been named, and each loan remains conditional on technical, legal, environmental, and financial requirements. The financing is a genuine accelerant, not a substitute for manufacturing capacity that does not yet exist at scale. The single most consequential long lead item in an AP1000 build is the reactor pressure vessel, the steel container holding the fuel, coolant, and reaction for the plant's operating life, and the network of facilities capable of producing its largest components at commercial scale is small, concentrated overseas, and already booked years out. Why reactor vendors need extremely large integral forgings. A reactor pressure vessel is not forged as a single seamless object. It is assembled from several exceptionally large forged sections, including shell rings, heads, flanges, and nozzles, welded together into the finished vessel. Vendors prefer those individual sections as large and integral as possible because every weld in a pressure vessel has to be inspected for decades of plant operation. Producing bigger single-piece shell rings reduces the number of welds and the long-term inspection burden that comes with them, which is why forging capacity, not welding capacity, sets the pace for how quickly components can be produced. The World Nuclear Association reports that very large Generation 3+ reactor components can require forging presses in the range of 14,000 to 15,000 tons, and, for some designs, ingots weighing 500 to 600 tons. Westinghouse has separately identified a 15,000-ton press capable of taking 350-ton ingots as its stated minimum for the largest AP1000 forgings, specifically, a distinct and smaller figure that should not be conflated with the broader Generation 3+ range. A small global supplier base, not one overseas press. The realistic supplier pool for AP1000 scale forgings is narrow, but not limited to a single machine. Japan Steelworks operates 2 14,000-ton presses in Japan and claims the largest share of the world's heavy nuclear forging market, with plans announced this year to double nuclear component production capacity by 2028. Doosan Enerbility in South Korea runs both a 13,000-ton and a 17,000-ton press, the latter handling ingots up to 540 tons, the largest single figure in the World Nuclear Association's global table. Taewung, also in South Korea, operates a 15,000-ton press. China First Heavy Industries and Shanghai Electric maintain heavy forging capacity in China, and several Russian facilities round out the list. Commercial qualification, export controls, and existing vendor relationships narrow which facilities can realistically supply a given Western design. But the constraint is a small qualified ecosystem, not a single overseas press without alternative. Throughput across that ecosystem is limited and uneven rather than fixed. The World Nuclear Association says roughly 4 pressure vessel sets per year has been common for large presses scheduled alongside other orders, though potential capacity varies. Japan Steelworks has reported the ability to produce up to 12 sets annually. Doosan and China First Heavy Industries, roughly 5 each, and Shanghai Electric around 6. The binding constraint is qualified, scheduled capacity at a specific facility, not a uniform industry-wide rate. Doosan's role in America's only AP1000 projects to date. Doosan Enerbility's Changwon complex is one of the most important qualified suppliers available to U.S. AP1000 developers, and it has already supplied major components for the 4 original American AP1000 construction projects. The 2 completed units now operating at Vaucla in Georgia, and the 2 at VC Summer in South Carolina that were left unfinished when construction stopped in 2017. Santee Cooper and Brookfield are evaluating a potential completion of the VC Summer units, though a final construction decision has not been made. Some original equipment remains at the site, but its condition, licensing status, and economic case for reuse would still need to be verified before it goes into an operating reactor. Fermi America provides an early example of how developers are responding to this constraint. In October 2025, it signed an agreement with Doosan to begin work associated with reactor pressure vessels and steam generators for its proposed Project Matador campus in Texas, well ahead of any construction start. Rolls-Royce SMR made a similar early supplier move in May 2026, selecting Doosan and the Czech firm Škoda JS for pre-production and manufacturing readiness work on nuclear island components, including the pressure vessel body for its small modular reactor design. That reflects early supplier engagement rather than a confirmed forging slot, and an SMR's vessel requirements are not necessarily comparable to the largest AP1000 forgings in scale. The U.S. has press force, but not an integrated heavy forging supply chain. Domestic capacity exists, but does not match the requirement. Allegheny Technologies operates a 15,000-ton press, meeting the nominal force Westinghouse specifies for its largest AP1000 components, but the facility handles ingots of approximately 175 tons, well below the 350-ton minimum Westinghouse requires. Lehigh Heavy Forge runs a 10,000-ton press, capable of roughly 270-ton ingots, and North American Forgemasters operates a comparable 10,000-ton press handling around 170 tons. The gap is not simply press force. It spans melt capacity, ingot size, component handling, precision machining, and nuclear qualification. An integrated production system, the World Nuclear Association says the U.S. never rebuilt after domestic nuclear orders dried up in the 1970s. BWXT remains one of North America's most important qualified nuclear component manufacturers, but its principal location for large commercial nuclear components is Cambridge, Ontario, not the United States. DOE's $17.5 billion commitment secures components before construction. The financing does not pay for 10 completed reactors. It helps Westinghouse and its eventual project partners order long lead components early, standardize purchases across projects, and reserve manufacturing capacity before individual construction schedules are finalized. The same logic already driving how utilities and manufacturers are reserving scarce transformer and switchgear capacity years ahead of need. A forging slot booked early is difficult to replicate on short notice, however well-financed a later entrant might be. Edwin Lyman, Director of Nuclear Power Safety at the Union of Concerned Scientists, has noted that the loan package is a fraction of what 10 reactors would likely cost in total. And none of the 5 potential projects yet has a construction contract in place. Britain's new press won't close the gap either. Sheffield Forgemasters, owned by the UK Ministry of Defence, is building a new forge for a 13,000-ton press as part of a broader £1.3 billion recapitalization tied mainly to the AUKUS submarine program. Installation is scheduled to run from July 2027 through roughly July 2028, after which commissioning and qualification work would still be required before the press could produce reactor-grade components. That press falls below Westinghouse's stated 15,000-ton minimum for the largest AP1000 forgings, so on its own, it would not eliminate the UK's reliance on overseas capacity for that specific design, though it would add qualified capacity for other reactor types and components. The World Nuclear Association is explicit that this challenge is not confined to reactor pressure vessels. It extends to steam generators, turbines, and other large engineered components, each drawing on an overlapping, similarly constrained set of qualified manufacturers. The practical lesson for utilities and financiers underwriting this wave of projects is not that one machine determines the schedule. It is that even projects clearing every domestic regulatory milestone still depend on an integrated global manufacturing base. The U.S. can finance its way into faster than it can rebuild. Sustainability Soundbites energy coverage is sponsored by Amazon. Visit the link in our show notes to learn more about Amazon's spotlight on energy. For sponsorship opportunities with Environment and Energy Leader, please reach out to a member of our team.